do all 9. And when you do your circles, make sure that you leave a little bit of space to put the numbers in. So let's start a new sheet and we'll just make the array of 9. Like I said, this is also could be somewhat therapeutic to, like, you can see my circles are actually kind of wonky. Then that's after a lot of practice of drawing circles. If you have students who have difficulty drawing circles or making the basic space, this is a nice way for them to get a better sense of working with the circle. I work with younger kids and I love Waldorf education. Anyone heard of Waldorf education? Well, they do a lot of work in the kindergartens with the circle, which is what we should be doing. But in the more conventional schools now, it's a lot of lining up and the kids can't see each other. And then they have a real hard time making circles, getting into a circle. Okay, now we're going to put the numbers in the middle. Depending on how your class is, if they have a hard time doing a group activity or focusing when you're doing it together, you can have them do it on their own and have them show you as they go along, or you can have them do it with partners. It depends on how well they're able to work as a group. Yeah, I also like to have them do separate colors because it's fun and learning should be fun and beautiful. Okay. So I might introduce this on a 3rd day of work. It doesn't have to be 3 days in a row. I would start asking them to share, like, what do you notice? And then have them first share with a partner.
Some of them are the same.
Which ones are the same?
1 and 9, 2 and 8, 3 and 7, 6 and 4.
So Miss Berry noticed that some of them are the same. Interesting. Anything else? And then you just acknowledge what the person said. You don't have to say, oh, you don't have to say good, or you could say interesting. Carol Dweck has that whole philosophy around the damages of praise. So a neutral statement can be beneficial, but to like repeat what the student said and then use a neutral statement. Anyone notice anything else?
I noticed that the ones that are the same all equal 10.
Oh, interesting. Does anyone see how that is? 4 and 6 equals 10. 1 and 9 equals 10. 2 and 8 equals 10. 7 and 3 equals 10. Interesting. Anyone else notice anything?
I noticed the patterns are kind of like angled across 5. So it's like diagonal 1 and 9, diagonal 3 and 7, like straight across 4 and 6, up and down 2 and 8. So it's like nice.
Yeah, so it's got this center point right here, that 5. Interesting. Good noticing. Oops, I praised. I can't help it. It's in my blood. Anything else people notice about any of them? They don't have to be in relation to each other, but
The 1s, 3s, 7s, and 9s all hit all of the numbers.
okay. So 1, 3, 7, and 9 touch every number. And so what about the ones that don't hit every number?
They don't hit the odd numbers, except for 5.
So which ones don't hit the odd numbers?
2, 4, 6, and 8.
Anything about 2, 4, 6, and 8?
They're the even numbers.
The even numbers. Interesting. So now if you have students who really don't have a number sense, they might be going, like what? You can tell if someone doesn't have a number sense if they're multiplying even numbers and they're getting odd numbers. So this is a really quick, easy, dirty test taking trick too, that they can look out for. Beyond knowing that if you're multiplying by 10, it's going to end in a 0. Now you know you're multiplying by any even number, it's going to end in an even number. You will never get an odd number. There's so many ways of using these patterns in mental math that will give you the endings really, really quick. The end number is always going to be the same in the pattern. So anyone else notice something? You can kind of choose words that you want to pull out depending on your student body and what you think they need to know, but it's not a bad idea to like work reminding them even odd. I know these are basics, but that's what this is. It's like going back to those basics so that you can have a new way of kind of relating to those numbers, getting back into that real number sense and awakening that mathematical mind.
0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Keep going.
11, 12, 13, 14.